Hi, Assalamualaikum. In this video, we will continue with example 3 under optimization using second derivative test. Okay. A rectangular storage container with an open top needs to have a volume of 12 meter cube. The length of its base is triple the width. Material for the base costs Rm10 per square meter. Material for the side costs Rm6 per square meter. Find the cost of the material for the cheapest container. Okay. Alright. So to solve this question, okay, we start with first step. Draw a picture of the physical situation. Okay. So from here we have rectangular storage container with an open top. Okay. So we have rectangular container here. Okay. With X, okay, and then the length of its base is triple, okay, the width. So we can write 3x here, and then height we can write y, okay, and then this is an open top, okay. Okay, this is the physical situation, okay, the picture of the physical situation. Alright, and then we continue with step 2. Yeah? Equate an appropriate formula to the given value. And then we write y as a subject. We're naming it as equation 1. Okay? So from here, okay, we have volume equals to 12 meter cube. Okay? Volume of V equals to 12 meter cube. So, for the given value, we start with volume V equals to 12 meter cube. Okay. And then we equate an appropriate formula. So an appropriate formula is volume for this box. Okay. 3x times x times y. So we get this. Okay. We equate to the given value here. Okay. Then we simplify, so we get x squared y equals to 4 because we divide 12 here by 3 here. So we get equals to 4. Okay. So we write y as a subject. So we get y equals to 4 over x squared. Then we naming it as equation 1. Right. Then we can continue with step 3. Write another relevant formula, naming it as equation 2. From rectangular storage container here, this is three-dimensional diagram. Okay, and under three-dimensional diagram, beside volume formula, okay, we also have surface area formula. Okay, so we can continue with surface area of the open rectangular storage or A. Okay, alright. From this diagram, okay, surface area of the open box or open rectangular storage container, okay, for the length of its base is triple the width, okay, we have one piece of bottom here, okay, plus two pieces of right and left side, plus two pieces of in front and back, in front here and back here. Okay, alright, so we can write surface area equals to 3x squared. 3x squared here come from one piece of bottom, 3x times x. And then plus, okay, for right and left side, we have area x times y from here. Okay, and we have two pieces, so we times 2 here. Okay, and then plus two pieces of in front and back. Okay, so we have 3x times y. Okay, and then we multiply by 2 because we have two pieces, okay, of in front and then back side. Alright, okay, then we simplify, so we have a equals to 3x squared plus, we simplify this, so we have 8xy. Okay, and then from surface area, okay, we can find the cost. Okay, because from here, okay, we have base cos and then the word is square meter. Square meter here means area. So area, surface area is related to cos. Okay, so cos equals to, right, from here, base cos RM10 per square meter. So base here, okay, this is base, bottom. Okay, so we multiply by 10 because 3x squared here means base. Okay, we multiply by 10 and then material for the sides cost RM6 per meter square. Okay, okay, before that, side here means right, left and in front, back. Okay, from here 2xy plus 2 times 3xy, which is 8xy. So we multiply by 6. Okay, okay, then we simplify, so we get cos or C equals to 30x squared plus 48xy. Okay, then we're naming it as equation 2. Okay, this is another relevant formula, which is cos we get from surface area formula. Okay, alright, then we continue with step 4. Okay, substitute equation 1 into equation 2. Okay, so from equation 2, we have cos equals to 30x squared plus 48xy. Okay, this is cos formula in terms of variable x and y. Okay, then we replace y equals to 4 over x squared because we want cos in terms of variable x only. So after we simplify x and x here, then we get 30x squared plus 48 4 over x. Okay, and cos equals to 30x squared plus multiply 48 by 4, so equals to 192 over x. Okay, so this is cos formula in terms of variable x. Okay, so from this cos formula in terms of variable x, we can find the cost of the material. Okay, right, from the previous slide, we get cost formula in terms of variable x. Okay, and then to differentiate, we can write cos equals to 30x squared plus 192x to the power of negative 1. Okay, we move denominator x here using properties of indices, so we get times x to the power of negative 1. Okay, okay, we want to find the cost of the material for the cheapest container. Okay, so we need to differentiate cost here. Okay, step 5. We need to find dc over dx. Okay, means that we differentiate from cost here with respect to x. So when we differentiate, so we get dc over dx equals to, we have constant 30 here and then we differentiate x squared using power rule. So we get 2x here. And then plus, we still have constant 192 here. Then we differentiate x to the power of negative 1 using power rule. So we get negative x to the power of negative 2 here. Then we simplify. So we get dc over dx equals to 60x minus 192x to the power of negative 2. Okay. Alright. Then we continue with step 6. Okay. When dc over dx equals to 0, we need to find the value of x. Okay, so from dc over dx here, we have 60x minus 192x to the power of negative 2. We equate to 0. Okay, then to solve and to find the value of x, okay, we can move x to the power of negative 2. We move to denominator, so we get this. Then we can write 60x equals to 192 over x squared. Then we cross multiply. So we get x cubed equals to 192 over 60, which is equals to 3.2 using calculator. Then we can write x equals to cubic root of 3.2, which is 1.47. Okay, and then from volume here, okay, they are given in terms of meter. cube. Okay, so means that x equals to 1.47 meter here. Okay, because x is the length. Okay, from the previous slide, we get x equals to 1.47 meter. Okay, then we continue with step 7. Find d2c over dx2. Okay, the question is find the cost of the material for the cheapest container. Means we need to show that d2c over dx2 greater than 0 or has positive value. So to find d2c over dx2, we need to differentiate from dc over dx, which is 60x minus 192x to the power of negative 2. So after we differentiate, so we get d2c over dx2. We differentiate 60x, we get 60. And then we differentiate negative 192x to the power of negative 2. We get 384x to the power of negative 3. Then we move down. So we get d2c over dx2 equals to 60 plus 384 over x cubed. Okay, using the properties of indices. Okay. Alright. And then when x equals to 1.47 meter, or in other words, when x cubed equals to 3.2, we can find d2c over dx2 either positive or negative. So we replace x equals to 1.47 here. Then we need to put bracket to the power of 3. Or we can straightforward substitute x cubed here. Okay, so we get 3.2 here. Then we solve using calculator. So we get d2c over dx2 equals to 180, which is positive value. And in other words, greater than 0. So means that if d2c over dx2 has positive value, okay, so we will get smile graph. Okay, smile graph here means minimum or cheapest. Okay, alright. So we can write x equals to 1.47 meter will minimize the cost. Okay, because we differentiate from cost here. Okay. So the word is minimize the cost. Okay. Right, and then from here, so we can write minimum or cheapest cost equals to C from cost formula. C equals to 30x squared plus 192 over x from the previous slide. So now we replace x by 1.47 meter. So we get this, and then we solve using calculator. So we get 195 over 44. So the cheapest cost equals to RM 195.44. Okay, or 195 ringgit 44 cents. Okay, so cost here from the given question is RM. So we can put RM here. Okay. Coming up next, more examples involving optimization. Thank you for watching. Stay tuned. Bye. Assalamualaikum.